This is the video for 12.3 area of composite figures. So the first thing we need to know before we can even get started is the different area formulas for different figures. Because a composite figure is multiple figures put together, but we'll get over that in a little bit. So the area for a parallelogram is just your area equals your base times your height. Simple as that. Your triangle, I hope this is one you all remember as well. Your area equals 1/2 times your base times your height. The area of a trapezoid is your area equals 1/2 times your height times your base 1 plus your base 2. So the sums of what your bases are. And your area of a circle is your area equals pi r squared, making sure you're squaring that r first. So what is a composite figure? A composite figure is made up of two or more shapes put together. So you have, it would be something like a square with a triangle on it and then half a circle over here. So to figure out what that area is, you need to break it down into areas you know how to find. So we would figure out the area of our square here, plus the area of this triangle, plus the area of this circle. So here's what we can do right away. We can find the area of this composite figure. So we've got a rectangle and a triangle. So the area of our rectangle is our base, 23, times our height, 15. So the area of the rectangle, I'm just going to punch this into my calculator, 23 times 15 is 345. And do not forget your units, so inches cubed. So we've got that one taken care of. Now we've got this triangle over here. So the area of our triangle is 1/2 times the base, which how do I figure that one out? Well, this side's 15, so right here should be 15 plus 6 up there plus 6 over there. So 15 plus 6 is 27 times our height of 8. So 27 times 8 is 216, and then half of that is 108. So the area of our triangle is 108 inches squared. The area of the entire figure is the area of our rectangle plus the area of our triangle. So 108 plus 345, getting us the total area of 453 inches squared. Very important that you are including that unit as well. And finally, we have a ceiling tile covers 3 square feet. So one little tile is 3 square feet. We want to know how many of these little tiles are going to fit on the octagonal ceiling, I don't know why I spelled it like that, sorry, shown below, so over here. So we got to break her down. First thing we'll do is we will find the area of the rectangle, because that's the easiest one for me. So the area of our rectangle is our base of 18 times our height of 20 to get us 360 feet squared. Then we've got these two trapezoids over here as well. The one on the top matching the one on the bottom. So we're going to take the area of our trapezoid on top, which looking back, the area formula is 1/2 h times the sum of the bases. So that's 1/2 times the height of 5 times the sum of our bases, so 18 plus 10. So 18 plus 10 is 28, times 5 is 140, and half of that is 70. So the area of the trapezoid is 70. And there's 2 of them, so that gets us to 140 feet squared. And we need to add that with our 360 to get the total area of 500 feet squared. But we're not done. It wants us to know how many of these 3-foot tiles can fit into our 500 feet. So then you just take 500, divide that by 3, and we could fit about 166 tiles into that area.